So the next section is on the product and quotient rules. So I briefly touched on this in the last video. So we can find the derivative of a polynomial using the power rule each term by just taking the exponent down and subtracting one. Now the question comes, what if it is two functions multiplied together? I can't do that. Okay. So the product rule can be used when I have the product of two functions. And the product rule says, it's going to seem a little confusing, but it's really not that bad. Okay, I'm going to take the derivative of the first function, so f prime of x, times the second function. I'm going to add the first function times the derivative of the second function. Okay, and I can use the other notation to make it look a little easier, and I can say it's the same thing as f prime times g plus g prime times f, or f g prime. Okay, so see if you see what I'm talking about. The first example, I have two functions. X is f, e to the x is g. So I can't just find the derivative of each. It wouldn't just be the derivative of the first one times the derivative of the second one. I have to use the product rule. Okay, so product rule, what's the derivative of x? It's 1. So that would be the derivative of f times g. G is just e to the x, plus, okay, f exactly how it is times the derivative of g, which is e to the x. Okay, so if I label these, this would be what? This is f prime times g plus f times g prime. And then to simplify it, I can factor out an e to the x, and I'd be left with 1 plus x, or x plus 1. Okay, so from here, you don't have to do, a lot of times if we were trying to solve the derivative, if it said, find where the tangent line's horizontal, that's how I'd solve it, by factoring. Next example. Okay, so one approach to this, if I wanted to find the derivative of this, would be to multiply it out first, then you could just use the power rule. What I'm going to do is use the product rule the way it is. Okay, so the derivative of the first function would be what? 2x. Okay, times the second function, which is 3x cubed minus 4x squared minus 5x minus 1. 5x minus 1 plus the first function, leave it exactly how it is, x squared plus 3 times the derivative of the second function, which is what? 9x squared minus 8x minus 5. Whoops. Minus 5. I keep hitting the next slide. Okay. To simplify this, I'd have to distribute the 2. Okay. And then combine like terms. So you could do this algebra. Distribute the 2x to all of these. And this I'd have to multiply out. So multiply the x squared by all 3 terms and the 3 by all 3 terms in order to simplify it. So I would have what? 6x to the 4th minus 8x to the 3rd minus 10x squared minus 2x. And then here I'd have plus 9x to the 4th minus 8x cubed minus 5x squared plus 27x squared minus 24x minus 15. I'm just multiplying this by these 3. Combine like terms and you would get 15x to the 4th minus 16x to the 3rd plus 12x squared minus 26x minus 15. You guys have been complaining you want more algebra. There it is. Okay, these are going to have a lot of algebra in the simplifying, but the actual rule is derivative of the first times the second plus the first function times the derivative of the second. And then I'm just going to simplify it. Okay. Next example is using the product rule, where I have the first function is the root x, the second function is just g of x, and then it's telling me what g of 4 and g prime of 4, so I can still use the product rule even in function notation. So the derivative of root x is, remember, root x is the same thing as x to the 1/2. So it would be 1/2 x to the negative 1/2. Okay, that's the derivative of root x times g of x plus, leave f the way it is, times the derivative of the second function, which would be g prime of x. So that's using the product rule, where the first function is x to the 1/2, the second function is g of x. So I'd have the derivative of the first function times the second plus the first function times the derivative of the second. Now this problem wants me to find f prime of 4, so now I'm just going to plug 4 in. So I'd have 1 over 2 root x to the, 2 root x times g of x, I just simplified that, plus root x times g prime of x, and now plug 4 in. So I'd have 1 over 2 root 4 times g of 4 plus the square root of 4 times g prime of 4. Okay, so this first gives me 1/4. G of 4, they tell me in the problem, is what? 2. Plus 2 times g prime of 4 is 3. Okay, so I have what? 1/2 plus 6, so I have 6.5. This is just very common where you have to use the product rule or the quotient rule in function notation. Okay, so here's the quotient rule. So when do you use the quotient rule? When I have, if you look at example 18, I have the quotient of two polynomials. Okay, I cannot divide everything by x cubed plus 6. I can't simplify it. So the quotient rule says to take the derivative of the numerator times the denominator minus the numerator, times the derivative of the denominator all over the denominator squared. Looks crazy, but you'll remember that after one day of practice. Okay, the other notation that makes it a little simpler right over here is f prime times g minus f times g prime all over g squared. Same thing, this is just using function notation, this is just using f and g. Okay, so first example, derivative of numerator would be 2x plus 1 times denominator, x cubed plus 6, minus the numerator, x squared plus x minus 2, times derivative of denominator, which is what? 3x squared. All over the denominator squared, x cubed plus 6 squared. Okay, and then I would multiply this out, combine like terms. So if I multiply it out, we get what? 2x to the 4th plus 12x plus x cubed plus 6, okay, minus 3x to the 4th, minus 3x cubed, plus 6x squared. Distribute this minus all over x cubed plus 6 squared. And then let's see what we can combine. I have what? Negative 1x to the 4th, if I combine those two. Okay, here and here. I have x cubed minus 3x cubed would be minus 2x cubed. All I'm doing is combining like terms now, guys. Plus 6x squared plus 12x plus 6 all over, I don't know if I'm going to be able to fit it, the denominator x cubed plus 6. Okay, so now I need to find the slope of that. So I need to find the derivative when x is 1. So now I need to plug 1 into that. So I'd have e to the 1 times 1 plus 1 minus 2 over 1 plus 1 squared which is what? I'd have e times 0. So it would be 0. 0 divided by, what's that? 1 plus 1, 2, 4. 0 divided by 4 is 0. So all of that for a slope of 0. So my tangent line would be y minus e over 2 equals 0 times x minus 1. Or you know that you just have a horizontal line, so it's just y equals e over 2. Okay, how do I know that? Because the slope is 0, so it's a horizontal line, so it's y equals the y value, which is e over 2. Okay, so but in order to find the slope of the tangent line, we had to find the derivative of that function. All right, last problem, find the derivative of that function. I just threw this in here because I want you to recognize from last section, if the denominator is a single term, you do not have to use the quotient rule. what I'd want you to do is just simplify the function first. So this function is the same thing as what? Just do 3x squared divided by x, which is what? 3x. And then 2 root x over x is what? Just do, that's x to the 1/2 over x to the first. So that would be plus x to the negative 1/2. If you, and I forgot the 2, plus 2x to the negative 1/2. Now I can just find the derivative of each term. So the derivative of that would be 3 minus, when I bring the 1/2 down, I get 1x to the what? Negative 1/2 minus 1. If I subtract another one from that, I have what? I'm just thinking, sorry guys. Negative 1/2 minus 1 is negative 3/2. So there's my derivative, 3 minus x to the negative 3/2. And that's it. But you want to break it up first before you find the derivative. Okay, I want to just simplify first, divide everything by x. When can you do that? When the denominator is one term. If it's more than one term, I can't do that. Okay, and if we wanted to, we could write this as 3 minus 1 over x to the 3/2, or the square root of x cubed. There's your derivative. Okay, so last thing I have, table of your formulas so far. Really, it just talks about the derivative of a constant. So just to kind of, the derivative of a constant of c is what? 0. The derivative of x to the n is n times x to the n minus 1. The derivative of e to the x is e to the x. The derivative of c times f of x is c times the derivative. That's just your constant rule. You multiply. Okay? And then we have addition, subtraction, and then now we have the product rule and the quotient rule. You can look in your book, quotient rule. But those are really the derivative rules we have so far. And they're in the front of the room. They will be on a poster board, so you'll always see them.